Today we're going to explore an extraordinary idea, one that stretches across both science and philosophy, challenging how we think about reality itself. We'll look at the universe not just as a collection of objects and events, but as something far more profound, a system shaped by invisible patterns and interconnected relationships that guide everything we see and experience. This journey begins with David Bohm, a physicist who proposed a radical view of the universe. Bohm introduced the concept of the implicate order, a deeper, hidden level of reality where everything is fundamentally interconnected. What we experience in everyday life is the explicate order, the world of distinct objects and events which emerges from the unseen implicate order. For Bohm, the explicate order is a kind of projection, a manifestation of deeper, enfolded relationships. What I want to share with you today is a way to give Bohm's vision more structure. We'll be using triadic logic, three-part systems of interlinked relationships, to understand how this invisible structure shapes the reality we experience. In this view, the implicate order is not just a hidden realm, but one governed by precise logical relationships, a deeper architecture that can be uncovered using triadic systems. Imagine that beneath the surface of everything we see, beneath the interactions of people, the workings of nature, even the movement of galaxies, there is a network of logical relationships. These relationships define how objects, systems, and processes interact and unfold. Bohm's implicate order can be understood not as a formless background, but as a structured system of stable, self-sustaining patterns of relationships. These patterns can be best understood through triads, three-part systems that define how different elements relate to and influence each other. A triad isn't just a group of three things, it's a specific kind of interlinked system where each element depends on and reinforces the others, creating a dynamic, stable structure. These triads reflect different types of relationships, whether that's causal dynamics, feedback loops, or nonlinear interactions. Each triad offers a blueprint for understanding how systems in the visible world behave by mapping the hidden logical relationships that sustain them. Let's explore how Bohm's implicate order works in nature using a specific type of triadic logic, conjoint systems, which explains how systems maintain stability through interlinked relationships. In this triad, three elements, let's call them A, B, and C, are interdependent, meaning that one element brings the other two into relationship, creating a stable, reinforcing structure. Imagine that B acts as a catalyst, linking A and C together, driving their interaction and keeping the system in balance. Take photosynthesis as an example. In the explicate order, we observe a plant using sunlight to convert water and carbon dioxide into oxygen and glucose. But in the implicate order, there is a stable underlying structure that governs this process. In this triadic system, sunlight, B, is the driving force that links water, A, and carbon dioxide, C, creating a stable ongoing reaction. The biochemical rules guiding this process are hidden in the implicate order, forming the logical pattern that sustains it. Thus, the explicate order, the process we observe, unfolds from a deeper hidden implicate order, the triadic relationships of photosynthesis, that ensures the stability and continuity of the system. In Bohm's model, the explicate order unfolds from the implicate order, guided by deeper relationships. This fits well with triadic logic, particularly in describing causal chains and feedback loops. Causal influence. In this triad, one element in the implicate order triggers a chain of events that unfolds into the explicate order. It's not just linear causality. What we observe is influenced by deeper, unseen relationships. For example, cell division, mitosis, unfolds from the implicate order through causal influence. The genetic code, A, provides instructions, molecular interactions, B, make division possible, and the process of cell replication, C, unfolds in the explicate order. The underlying genetic logic in the implicate order remains hidden, but it drives the entire process, feedback and reversion. Feedback occurs when the explicate order affects the implicate order, altering its structure and creating new outcomes. In climate systems, for instance, greenhouse gases alter atmospheric flows. B, which feeds back into the implicate order of energy patterns. A, changing how the system unfolds over time. This feedback loop shapes the patterns we experience in the explicate order. aligning with Bohm's idea that disturbances in the manifest world can alter deeper enfolded structures. Nonlinear influence describes how small changes in one part of a system can produce disproportionate outcomes in other parts. Bohm's implicate order, with its dynamic enfoldment and unfolding, mirrors these nonlinear dynamics. In a nonlinear system, influences don't flow predictably. Instead, A influences B indirectly through C, creating loops that magnify or alter the final outcome. This reflects the idea that the explicate order is often an unpredictable manifestation of complex, underlying relationships. Consider evolution in ecosystems. A slight environmental change, A, can influence survival rates, C, in unpredictable ways by reshaping genetic selection pressures, B. This leads to a complex, cascading set of changes in the explicate order governed by the deep, hidden relationships in the implicate order. By framing Bohm's implicate order through the lens of triadic relationships, we can see how the hidden architecture of reality works. Triads offer a structured, logical system for understanding the deeper, enfolded patterns that Bohm suggests guide everything we observe in the explicate order. In this perspective, the implicate order becomes the blueprint for all of reality, a system of interlinked relationships that define how things unfold. Whether in nature, biology, or the cosmos, the manifest world is a reflection of stable, self-sustaining triads operating in the implicate order. Bohm's universe, when seen through this triadic lens, reveals a dynamic, logical structure that underpins the fabric of everything we experience. In this way, we can think of the implicate order not only as a source of interconnected unity, but as a precise, structured system of relationships that govern the unfolding of the visible world.